Welcome to the deep dive. We're going to be doing a deep dive today. Get it? Deep dive.
Very funny.
Oh, come on. Got to have a little fun, right? Especially since today we're talking about something pretty serious.
That's right.
Alzheimer's disease.
A topic I'm sure is familiar to all of you listening.
Especially since, well, you're all eye doctors.
And today we're focusing on some fascinating research about the potential for retinal imaging to actually detect and monitor Alzheimer's and other neurodegenerative diseases.
I know. It sounds crazy. You're like, what does the eye have to do with the brain?
Well, more than you might think.
We'll be taking a look at a 2021 journal article from Alzheimer's and Dementia. It's got a really long title.
Retinal Imaging in Alzheimer's and Neurodegenerative Diseases.
That's the one. It brought together experts from all over the world to discuss this very topic.
And we'll be sure to link to the full article in the description.
So you can check it out for yourselves after the show.
Now, as you know, diagnosing Alzheimer's early on is a huge challenge. Current methods like amyloid PET imaging and CSF testing, those work, but they're expensive.
Yeah, and not easy to access for everyone.
Retinal imaging, though, that's already a common tool in your practices.
Right, exactly. So let's break this down. Why the retina? What makes it so special when we're talking about brain diseases?
Well, for starters, the retina is actually a part of the central nervous system.
Really?
It's directly connected to the brain. They share a lot of similarities in terms of structure and even some of those same pathological pathways.
Wow, I had no idea.
And here's the really cool part.
What's that?
The retina is the only part of the central nervous system that we can see directly, without being invasive, I mean.
So basically, every time we look into a patient's eyes, we're getting a glimpse of their brain. That's pretty wild.
It is, and that's why researchers are so excited about the potential of retinal imaging for Alzheimer's.
Okay, so what exactly are researchers seeing in the retina? What kind of changes are linked to Alzheimer's?
One of the things they found is that people with Alzheimer's, and even folks with mild cognitive impairment, or MCI, they often have thinning of certain retinal layers, especially the retinal nerve fiber layer, the RNFL.
RNFL. Interesting. We already use OCT to look for RNFL thinning in glaucoma patients, right? Could this mean we're missing something when it comes to Alzheimer's?
That's a great question, and it's something researchers are definitely looking into. It turns out that the pattern of RNFL thinning can actually be different between glaucoma and Alzheimer's.
Oh.
In Alzheimer's, the thinning tends to be more pronounced in specific areas of the retina, particularly the macula.
So the OCTs we're already using could actually hold valuable information about a patient's brain health.
That's the idea. It's like we have this powerful tool already. We just need to learn how to use it in a new way.
That's amazing. So by paying attention to these specific patterns of thinning, we could potentially differentiate between different conditions and maybe even catch those early signs of Alzheimer's.
Exactly. And that's not all. Researchers are also exploring some really cutting-edge imaging techniques to visualize amyloid plaques, you know, the hallmark of Alzheimer's disease.
Like actually seeing those plaques in the eye?
Yep.
I know the article mentioned something about curcumin imaging. Tell me more about that.
Okay, so curcumin. It's a natural compound found in turmeric. It gives turmeric its bright yellow color.
Ah, so that's what makes my curry so delicious.
Exactly. But it also binds to amyloid plaques. And here's the cool part, it fluoresces under special lighting.
So it's like a dye that lights up those amyloid plaques in the retina.
Basically.
Wow, that's incredible. What have they found so far with this curcumin imaging?
Well, studies using curcumin, combined with a scanning laser ophthalmoscope, or SLO, have been able to actually visualize amyloid deposits in the retinas of living patients with Alzheimer's.
In living patients, that's huge.
And, get this, the amount of amyloid in the retina seems to correlate with the severity of the disease in the brain.
So we're not just seeing the amyloid, we're getting an idea of how bad it is. That's a game changer, right?
Absolutely.
You also mentioned another technique, polarimetry, right? I have to admit, that one's new to me.
Oh, it's fascinating. Polarimetry also lets us see amyloid, but it doesn't require any dyes.
No dyes.
Nope. It relies on how amyloid plaques interact with polarized light.
I vaguely remember polarized light from physics class. Something about light waves vibrating in a specific direction.
You got it. So when polarized light hits amyloid plaques, it causes a rotation in that plane of vibration. And by analyzing these shifts in light, we can detect those plaques.
That's so clever. So no dyes, no injections, just using light to see those amyloid deposits.
That's right. And, you know, the results so far are very promising.
That's great to hear. So curcumin imaging and polarimetry. both ways to see amyloid in the retina.
And there's more. There's also hyperspectral imaging, which captures a much wider range of light wavelengths than traditional imaging.
Wider range of light wavelengths. Okay, I'm intrigued. How does that help with detecting amyloid?
Well, amyloid has a unique signature in terms of how it reflects and absorbs light at different wavelengths. And hyperspectral imaging, it captures that entire signature.
So it's like we're scanning the retina for a specific light pattern that says amyloid is here.
Exactly. And you know what?
What?
Researchers have used hyperspectral imaging to successfully differentiate between individuals with MCI who had high amyloid in the brain, confirmed by P imaging, by the way, and those who didn't.
Wow, so it's not just about detecting the presence of amyloid, but also the amount of amyloid. That could be really valuable for diagnosis and prognosis, right?
Yeah.
And even for monitoring how a patient is responding to treatment.
Exactly. And the really amazing thing is that hyperspectral imaging isn't limited to human studies. They've used it to distinguish between mice that accumulate amyloid and normal mice.
So it's consistent across different species. That's pretty reassuring.
It is.
So all these different imaging techniques, they're like pieces of a puzzle. And each piece gives us a better picture of how retinal imaging can help us understand, diagnose, and manage Alzheimer's.
That's a great way to put it.
It's incredible how far this research has come.
Right. It's really exciting. But this is just the beginning. There's still so much more to explore.
There is.
So before the break, we were talking about how retinal imaging can be used to detect Alzheimer's. We looked at changes in the retinal nerve fiber layer and those amyloid plaques.
Right. The things we can see in the retina that might tell us something is going on in the brain. Pretty amazing stuff.
It is. And don't forget, all of you listening are eye doctors. You're the ones who will be using this technology.
Yeah. It's like you're at the forefront of a whole new era in brain health.
Exactly. And today we're going even deeper. We're going to talk about another aspect of retinal imaging, the retinal vasculature.
Okay, so that's the network of blood vessels in the retina, right? The ones that keep the retina healthy and working properly. We already know that vascular health is important for the brain. So it makes sense that if something's off with the blood vessels in the retina,
it could be a sign of something going on in the brain too. You got it.
So the retinal vasculature is kind of like a mini version of the brain's vascular system.
Exactly. They share a lot of similarities.
Yeah.
In terms of structure and how they work. And they both can be affected by aging, inflammation, high blood pressure, things like that.
Right. So let's say we're looking at a patient's retina and we see some signs that the blood vessels aren't healthy. Does that mean there could be something wrong with the blood vessels in their brain too?
That's what researchers are thinking. And there are some really amazing imaging techniques we can use to visualize and analyze the retinal vasculature.
Yeah.
Like OCT angiography or OCTA.
OCTA. I know OCT is used to look at the structure of the retina. How is OCTA different?
Think of it like a super-powered OCT.
Super-powered.
It uses this really cool technique to see the blood flow within the vessels. It's like having a moving map of the retinal circulation. You can see exactly where the blood is going and how fast.
Whoa, hold on. So instead of a static image of the vessels, we can actually see the blood moving through them.
In real time. Pretty cool, huh?
That's amazing.
Yeah.
Okay, so what has OCTA shown us about the retinal vasculature in Alzheimer's patients?
Well, a lot of studies have shown that folks with Alzheimer's and even MCI have a decrease in microvascular density.
Microvascular density, meaning?
There are fewer blood vessels in the retina.
Fewer blood vessels. So does that mean the retina isn't getting enough blood?
Yeah, that's the concern. It could be because they're losing capillaries, the tiny vessels that bring oxygen and nutrients to the retinal cells.
Like the retina is being starved of blood.
That's one way to think about it. And this vascular starvation might be reflecting similar changes in the brain, which could contribute to cognitive decline and dementia.
It's like a domino effect. Something goes wrong with the blood vessels in the brain. Then it affects the retinal vessels. And those changes in the retina can be an early warning sign of what's happening in the brain.
You got it. And you know what's even more interesting?
What's that?
Some studies have suggested that these microvascular abnormalities, they might even be present before any cognitive symptoms show up.
Before any symptoms. So we could potentially catch Alzheimer's even earlier.
That's what we're hoping for. Early detection and intervention are key.
That's incredible. And it's not all about just counting blood vessels, right? Didn't you say that OCTA can also look at how well the vessels are functioning?
Yep. It can measure things like vessel caliber, which is how wide the blood vessels are.
Yeah.
And blood flow velocity, how fast the blood is moving.
Okay, so not just the number of vessels, but also their quality, so to speak.
You got it. And guess what studies have found?
Tell me.
People with Alzheimer's tend to have narrower retinal blood vessels. and slower blood flow, so their vascular system isn't working as efficiently.
That's fascinating. All these little changes in the retinal vessels, they can tell us so much about what's happening in the brain. It really shows how complex Alzheimer's is. It's not just about amyloid plaques, it's also about the blood vessels and inflammation.
It's a multifaceted disease, for sure. And retinal imaging is giving us all these new tools to understand it better. We're putting the pieces together, one image at a time. And you know what else is really exciting?
What's that?
All the collaboration that's happening in this field. Researchers from all over the world are working together, sharing their data and findings to move things forward faster.
That's great to hear. But I know that standardization has been a challenge in retinal imaging, especially with so many different techniques and protocols being used.
Right. But there's been a big push to develop some standardized protocols for image acquisition, analysis, and interpretation.
So if everyone's using the same settings, the same software, the same criteria.
Exactly.
Yeah.
Then we can compare results from different studies and populations more easily. It's like we're all speaking the same language, the language of retinal imaging.
I like that. And what about data sharing? I've heard that's becoming more common in research.
It is. There's this growing movement towards open science, where researchers share their data and findings publicly so others can use it and build upon it.
That's fantastic. It's like creating a global brain trust where everyone can contribute their expertise and work together to find solutions.
I love that analogy. And there are actually platforms and databases specifically designed for sharing retinal imaging data in Alzheimer's research.
Wow, so researchers can access and analyze tons of data from all over the world.
Exactly, and that leads to faster discoveries and better insights.
So we're moving away from a fragmented approach to a more unified and collaborative one.
That's the goal. And this collaborative spirit, it's not just in research, it's also happening in clinical practice. Organizations like the Alzheimer's Association are working to translate research findings into practical tools and guidelines for healthcare providers. So what we learn in the lab can actually be used to help patients.
That's a crucial step, bridging the gap between research and practice. All of this is really exciting. But I'm curious, what does it all mean for the patients we see every day?
That's the million-dollar question, isn't it? And that's what we're going to talk about next.
Okay, I'm ready. Let's talk about how all of this research might actually change the way we approach Alzheimer's care. So we've spent this whole deep dive talking about how cool retinal imaging is and how it could be a game changer for Alzheimer's.
It's pretty amazing.
But how is this actually going to affect our patients, like the people we see in our practices day to day?
That's what matters most, right? Actually using this technology to make a difference.
Exactly. So let's say a patient comes in for their yearly eye exam.
Right.
And maybe they've been a little forgetful lately. Maybe they're a little worried.
We've all had those patients.
And right now, we'd probably recommend they see a neurologist, right?
Yeah, that's the standard of care.
But that can take a long time.
It can. Lots of waiting, lots of tests. It can be stressful for the patient and their family.
And sometimes it's still hard to get a definite diagnosis, especially early on.
That's the problem. But imagine this.
Okay, I'm imagining.
What if we could do some of these retinal imaging tests during the eye exam?
Right there in our office.
Yep. We could look for signs of RNFL thinning, check for amyloid plaques, see how healthy their retinal vasculature is.
All in one visit.
All non-invasive, too.
That would be like a whole new level of eye exam. We'd be looking at eye health and brain health at the same time.
That's the future we're talking about.
And then we could talk to the patient with more information.
Exactly. We could say, hey, these retinal images show some things that might be early Alzheimer's. I think you should talk to a neurologist.
It would be way more proactive and maybe even catch those early signs before it's too late to do something.
Early detection is key.
It gives the patient and their family time to plan, to make decisions, to find support.
And even if there isn't a cure yet, knowing the diagnosis early on is so important.
For peace of mind, for quality of life.
Absolutely. And retinal imaging isn't just for early detection either. It can help us monitor disease progression and see how someone is responding to treatment.
So instead of waiting months to see if a new medication is working, we could get feedback much sooner.
Potentially. We could see if we need to adjust the dosage. Or even try a different approach. It could really personalize treatment plans.
And what about clinical trials?
Oh, retinal imaging could be huge for that. It could provide a more objective measure of whether a new drug is working.
It could help streamline the whole drug development process.
And bring us closer to a cure. That's the ultimate goal.
It really does feel like a beacon of hope. for everyone affected by Alzheimer's. But we have to be realistic, right?
Of course.
There are still challenges. We don't have all the answers.
True. But the progress we've made so far is incredible. The research is moving so fast, and there's so much collaboration and innovation happening. It's really an exciting time to be in this field.
And it's exciting to be an eye doctor.
It is.
We have a chance to be on the cutting edge of this, to actually make a difference in the fight against Alzheimer's. But it means we have to stay informed, embrace these new technologies, and be ready to use them.
Absolutely. We need to educate ourselves and talk to our colleagues about this, advocate for the resources we need to make this happen, make retinal imaging for Alzheimer's available to everyone.
This research has really opened my eyes.
I see what you did there.
Okay, last pun, I promise. But seriously, it has shown us just how powerful the eye can be as a window into the brain. It's a reminder that we're not just eye doctors. We're guardians of brain health, too.
And we have a responsibility to use these advancements to improve the lives of our patients. The future of Alzheimer's care is looking brighter, and we, as eye care professionals, are a big part of that.
That's a great note to end on. We hope you've all enjoyed this deep dive into retinal imaging and Alzheimer's. Be sure to check out the link to the full journal article. It's in the episode description.
And if you're new to the deep dive, hit that subscribe button. And if you like what you heard today, leave us a 5-star rating. We'll be back soon with another deep dive into the world of science and medicine.
Until then, keep those minds sharp, those retinas healthy, and as always, keep exploring.